what's going on, and so you can see the people behind the scenes here.
And we're a person, and it's a suitcase. Hi, this is Caroline, and today I'm at the Russell Innovation Center for Entrepreneurs. Mark, tell me about Technologies of Color, Rice, and yourself.
Yes, I'm Mark Lawson. I'm the Director of Technology for Technologies of Color. We're an organization that helps Black people get into the technology industry and to improve their career. We're a part of the Georgia AIM project. AIM stands for Artificial Intelligence in Manufacturing. It's supported here at the Russell Innovation Center for Entrepreneurs, and I'm going to discuss object detection.
Okay, excellent. Let's talk about object detection. Okay, so what is object detection?
So what we're working here is you have the ability to use a webcam, and what it's going to be able to do is it has been programmed, or in this case trained, in order to identify individuals, things, and objects after being trained with a large data set. So it's basically mimicking the eye. The first thing we're going to notice here is that we have to select the model. We're using YOLO V5.
Okay, so tell me, YOLO V5, if you want to do this at home, number one, Google search YOLO V5, and I'm going to link to it below.
Hugging Face?
Hugging Face. It's on Hugging Face, and it's also on
GitHub
as well. So you can do this on any computer, any Linux-based computer.
Any Linux-based computer. We're currently using a Zima board, and you can find those, but also a Raspberry Pi, which it's very affordable. You can go out and grab a Raspberry Pi and do this exact same thing at your home.
Or you can do a Windows laptop or Mac or whatever,
yes.
Right? If you just have a regular computer. So Raspberry Pi, Zima board, or just a regular computer. Okay, right. Perfect. Okay, so YOLO V5.
All right, so then we're going to click here, which is going to load the model. We're going to select, so we're currently using a webcam. It is set up under channel 0. Here we have a couple different things, which I'll talk about in a second. But in order to get this started, initially, we click here. And now we can actually see based on what's going on. And so you can see the people behind the scenes here.
And we're a person, and it's a suitcase, yes.
All right. And so initially, as you can see, it sees both of us. There are a couple of chairs back there, etc. So this item here called detection confidence. Think of this as how sure you are of your assessment, right? So it's trying to determine what it's looking at. And right now we're going with a 25% confidence level, right? If we take that up, it has to be that much more sure of what it's looking at relative to what it's been trained on. If we take it down, right? So how you might use that is based on whatever it is that you're trying to do. In this case, it's also based on the camera, right? So if you're very far away, I use the example, if you saw someone walking in a crowded room and and you weren't really sure, would you yell out? Like, hey, Caroline, right? The closer you are to me, the more sure that I'm talking to you. If you're farther away, I'm not really sure, right? So that's kind of how the confidence level works here. If you have a very clear image, then the confidence level could be higher because you'd be more sure of what you're doing. If you have less of that, or if the things you're looking at are farther away, you probably want to take your confidence level down. Does that make sense?
Yes, absolutely. Okay. So there are trade-offs in technology, right? You can either be really confident and have, and be really sure and get exactly what you want, or you can be, a little bit more fuzzy about it and be like, well, it's going to be less accurate, but it's going to give me more results.
Right. Obviously, to make it more user-friendly, we have the ability to go in and change the color of the different objects that it's been trained on. So obviously, we have the person object, which we started off with. So there you are. And the suitcase that we're using over here to the right is red. So again, if I wanted to make it easier to determine what it is that I'm looking at, I can color code them. That pretty much makes sense. Here we have the thickness, so the line that is drawing around the things, we can change that and make it thicker. That's also affecting the label.
Can it do water bottles?
Yes, actually.
Okay, let's try the water bottle. So there's my water bottle. Oh, and it can recognize your keyboard and your mouse. So how many images did you train it on?
We had a data set of images. So think of hundreds, thousands of images. And the thing to be aware of is because we're looking at something in 3D, right? I don't need just an image of a person, from their profile or from the front. I need several different images, right? In order to, so not just several different images of myself, but of several different things that we would consider a person from several different angles, right? So as we were seeing earlier, if you take this same water bottle, right, it's not sure what it is because it wasn't trained to look at it from that angle.
But if I do it up and down, it's a water bottle
Yes,
again.
right.
Yes. So basically, to sum it up, use YOLO V5 on a Linux-based machine.
Yes.
And then the front end, you use.
So this front end uses a thing called Streamlit. So Streamlit is actually currently owned by a company called Snowflake. They bought it because it allows people who do a lot of programming who aren't familiar with the front end to actually create a front end really easily. So this is a combination of Python and Streamlit.
Basically, you created the model, you trained the model on thousands of images in different orientations, and then now people can use it to do object identification.
Yes. Oh, and I also want to point out Streamlit is completely free.
And downloading repositories on GitHub, also completely free. And we will link to that below in the video. Use cases in manufacturing could be telling if a part is defective. Is that a use case for manufacturing?
Right. Actually, you can determine based on different types of parts. So if I bring in a set of parts here, we have this. So if we bring that closer, right? So if you wanted to follow this part through its manufacturing, right, I could take the various versions of the part and then have the manufacturing going on, and they're all on the conveyor belt, and it would be able to detect which part is which. Another way of using this in a manufacturing setting is personal protection equipment. Let's say that you're in a warehouse.
PPE, we all learned about PPE during the pandemic, right?
Exactly, right? So let's say you entered an area and you were supposed to have a face mask on, or you're in a dangerous environment and you need a hard hat. The system can be set up to detect a hat on a person's head. So it's aware of what a person is and it's aware of a hat. And so I'm detecting to make sure that you have a hard hat. And if not, an alarm can sound, right? Because we don't want to get an OSHA violation, and we also don't want a person to get hurt.
Okay, perfect. So it's going to say, hey, where's your hat?
Yes.
Yes. And, or hey, where's your PPE? Are you in reminder PPE? Hey, you're not. I'm detecting it. So that's great. It's both for safety and for compliance.
Yes.
Perfect. All right. So thank you so much for joining me today, Mark. And we will give you more from the Russell Innovation Center for Entrepreneurs. Follow Russell Innovation Center for Entrepreneurs, RICE, on social, and also consider making a donation. Thank you very much.